So we are going to discuss some of the numerical problems on the convex and concave lens. Now I have taken some example which are given in our book. So example number 10.3, okay, page number 182. Example number 8.2. So see this example. What has been said? A concave lens has focal length of 15 centimeter. At what distance should the object from the lens be placed so that it forms an image at 10 centimeter from the lens? Also find magnification produced by the lens. So in the question, there is a concave lens. So suppose I am drawing diagram here. Okay, and the given values are focal length f equal to 15 centimeter and image distance equal to 10 centimeter. Now we have to find the object distance and magnification and also. Okay, so that thing we have to find. Now what we have read in the case of concave lens, it always produce a virtual image. Okay, so it has been said that there is a concave lens which produces a image of an object at a distance 10 centimeter from the lens. At a distance 10 centimeter from the lens. Now you might be in a question that whether I have to take this 10 centimeter toward right of the lens or in left of the lens. Where should you have to take that 10 centimeter? Because they are saying that image is forming at a 10 centimeter from the lens. It can be on the right of the lens, it can be on the left of the lens. Now we know that from the study of the lenses, from the ray diagram, that image formed by the concave lens is always on the left of the lens, means it is virtual and erect. It is forming this side of the image. Always it's forming on the left side of the lens. Okay, so this thing we know from our study. So if this thing we know that, so we can locate somewhere here. So this is the image distance. Okay, this is here the image is forming, and what has been given? The focus. Okay, the focus. So we can assume a object somewhere placed here. We don't know actually a distance, but we surely what we know, if the rays focus, what is focus? Focus is a common meeting point of the reflected ray in case of mirror, or common meeting point of the refracted ray in case of lens. Focus is defined as a common meeting point in case of reflected ray in case of mirror and refracted ray in case of lens. So if you know that if a ray is coming from this side, so this is a diverging mirror, this is a diverging mirror, so they are not meeting here, so they are not going to meet here. So they will, if we extend backward, they will surely meet backward. Okay, suppose you send another ray, so if you extend backward, they will meet here. Okay, they appear to meet here. This is the virtual and erect image they will find. So in this case, the focus. So I am defining the focus. Okay, I am defining the focus. So where the focus is there on this side, on this side. So we can, if the image is forming on this side, so surely the object is also on this left of the mirror, left of the lens, and focus is also on the left of the mirror. Okay, from our previous knowledge, that if suppose we are assuming that in case of a concave lens, the image is forming on the left of the lens, so therefore the object will also be on the left of the lens, and its focus is also on the left of the lens. Why? Because focus is defined as a common meeting point of the refracted ray, and here they are not actually meeting. You can see some parallel rays. Whenever you have to find the focus, assume a parallel ray. Okay, let them reflect or refract. After refraction, if they appear to meet, where they are meeting? To the left of the mirror. They are meeting at the left of the mirror. They appear to meet at the left of the mirror. So in that case, the focus is on the left of the mirror, the image is forming on the left of the mirror. That means that both are on the left side of the lens. Okay, sorry for I am pronouncing mirror. So here what has been given, that there is a concave lens, okay, and let's suppose this distance is v, okay, v equal to 10 centimeter, and here there is a focus, okay, and this distance f is given as 15 centimeter, okay. Now we have to find the object distance, okay. Now we have to apply the formula 1 upon v minus 1 upon u equal to 1 upon f. That is the mirror for, or that is the formula for the lenses. You know that it is somewhat different, because in the mirror we use positive symbol here, but in the lenses we use negative symbol, 1 upon v minus 1 upon u equal to 1 upon. According to that formula we have to find the object distance or image distance of the focal length, whatever it is. So first you have to assign sign, okay, as the image is forming here to the left of the lens, and suppose the object is also on the left of the lens, because in the case of concave lens the object is on the left of the lens. So the incident ray comes from this direction. Now all the distance are measured from the optical center. So this is the optical center. So to measure the v, you will go in this direction, okay. So this is opposite to our incident ray direction, okay. So or also it is all on the left of the lens, okay. So it's what will be its symbol? Its symbol will be negative. So we will assign negative value to u, b, and we will assign no value to u because it can be found out. The quantity which has to be found out, we assign no symbol to it. The result will tell you what the symbol is, okay. Minus 1 upon u. Now focus is also on the left of the mirror. You will go in this direction, that is opposite to the incident ray direction, okay. That is the incident ray, and this its direction is toward the right, and you will, if you are going to measure the distance from optical center to focus, you will go in the opposite direction of the incident ray. So that means focus is also, we assign negative symbol. Now our formula is ready, we have to put the values. Now 1 upon minus 10 minus 1 upon u equal to 1 upon minus f, f is 15. Now transfer this v to this side. So minus 1 upon u equal to 1 upon minus 15 plus 1 upon 10, okay. Now we will take LCM, and LCM will be 30 in this case. So minus 2 plus 3 equal to minus 1 upon u, okay. So it will be plus 1 upon 30 equal to minus 1 upon u, or u equal to minus 30 centimeter. Means object at a distance of 30 centimeter from the lens, and negative means it is lying of the left of the lens at expected, because in case of the concave lens with the image is forming here, so object will lie on the left of the lens, okay. So here the object is lying somewhere here, it is 30 centimeter away from the lens. So important thing is that we need not to we have to understand what the symbol, okay, what the symbol we have to assign in the formula. And beyond, there is a theory that what we have learned in case of this concave lens, the things which we have know, that it always form a virtual image. If it is forming a virtual image, that it is forming on the left of the mirror, not right of the mirror, it is forming on the left of the lens, okay. And for that the object will be on the left of the lens. So this thing we know from our previous study, okay. So don't skip that theory part, because it is very important. Now example number 10.4. Example number. Now you can also find a magnification in this case. One thing I have left, magnification is given by, in the case of lens, magnification is v upon u, simple v upon u, and you know that v is what? V is 10, okay, and u is here u is 30, and both are negative, okay. So in this case the magnification will be 1/3, Okay, magnification will be 1/3. Now example 10.4. A 2 centimeter tall object is placed perpendicular to the principal axis of convex lens of a convex lens of focal length 10 centimeter. So there is an object whose height is 2 centimeter and it is placed perpendicular to the axis of the principal lens, okay, whose focal length is 10 centimeter. The distance of the object from the lens is 15 centimeter, means here the object distance is given, and find the nature, position and size of the image, and also find its magnification. So we have to find the image distance, its nature and position and magnification. Okay, so firstly we have to draw a diagram. So consider a convex lens. Okay, now its object is 2 centimeter tall and object is placed 15 centimeter from the lens. Okay, so first I have to write the data. Here height of the object is 2 centimeter and focal length of the focus is 10 centimeter and object from the lens u is 15 centimeter. For that we have to find the image distance. Now first thing, we assume that object is placed left of the lens. So here it is object 2 centimeter tall. Okay, so this is the object distance. Now in case of lens, where do you consider the focus? Means will you consider the focus on this side? Will you consider the focus on this side? Either on the left of the mirror or on the right of the mirror. Where do you consider? So what I have defined? I have to find focus is a common meeting point of the parallel incident ray. Suppose from that object, because incident ray are coming from the object, so they are coming from object, and after refraction they will converge to this point, means focus will be somewhere here. Okay, so focus, don't be confused, focus is a common meeting point of the refracted ray after refraction. Okay, common meeting point of the intersection point of the refracted ray. Okay, so in this case the object is at the left of the mirror and focus is of the right of the mirror. So here this is the focus. Okay, now you can easily understand what sign we have to assign, because it is at the left of the mirror and it is opposite to the direction of incident ray. So u is considered negative, whether, and in the same case the f is considered to be positive because it is in the direction of refracted here it is in the direction of incident ray. So this is the direction of incident ray and focus is in the direction of incident ray. The distance you measure the focus from optical center to focus, you will go in this direction, it is the direction of incident ray. So all the distance which are in the direction of incident ray are considered as a positive. So now apply the formula 1 upon v minus 1 upon u equal to 1 upon f. Now assign the symbol 1 upon v, the quantity which has to be found, we will not any symbol to it, but u is negative. Okay, why? It is at the left of the lens, it is opposite to the direction of incident ray. So minus u equal to, and f is positive. Okay, now our formula is ready to use. Okay, now we have to apply the, so minus plus, so 1 upon u is 15, 1 upon f. Okay, so 1 upon v equal to 1 upon 10 minus 1 upon 15. Again the LCM is 30. So 3 minus 2 equal to 1 upon v, and here 3 okay. So here you will get v equal to 1 upon v equal to 1 upon 30 or v equal to 30 centimeter. Okay, so v equal to 30 centimeter, it comes out with a positive symbol. Positive symbol means it is forming on this side. it is forming on this side. And it can be expected in the case of the convex lens that convex rays form a real and inverted image. Generally the convex lens form a real and inverted image, and real and inverted image can be formed on this side, okay, on the right of the lens. So our answer is right. Okay, now we have to also find a magnification, or now magnification is height of the image upon height of the object up equal to V upon U. First you have to write this formula. Now assign the values, because we know that the object is lying on the principal axis, above the principal axis, so object height is positive. Okay, so the quantity which has to be found, we will not assign any symbol to it. So height of the image and height of the object, and it is positive. Why? Because it is lying above the principal axis. Now equal to V upon U. V is in this side. Okay, so it is positive. Okay, so 30, and U is in this side to the left of the lens, so it will be negative. So minus 15. Okay, so here what do you say? 15 to 30. This is a minus quantity. So a height of the image is minus 4 centimeter. Now image height is minus 4 centimeter, means image is forming, it is a real and inverted image, first thing, and it is enlarged. Okay, it is bigger than the object side, so it is enlarged image is forming. Okay, so enlarged image is forming. Now these are the questions of the lens. Questions are somewhat like that. Okay, first you have to know the theory correctly, theory of the lens, theory of mirror, and part of this one. Then you have to assign a values, okay, which is positive, which is negative, and this is very simple. It follows a very simple law. All the distances which are opposite to the incident ray are considered negative. All the distance which are in the direction of incident ray are considered positive, and so that proceed in this manner. Okay.